My name is Kelly Mahoney, and I'm a third-year student at the University of Minnesota College of Veterinary Medicine. My summer scholars project was part of a larger project to determine if existing computational programs, which were originally developed for humans, can predict the pathogenicity of missense variants in veterinary species. Specifically, I looked at horse data, building upon work already done to assess the performance of these programs on canine data. Missense variants will sometimes, but not always, alter protein or gene function and thus cause disease. Therefore, a successful application of these computational programs could be very useful to help distinguish missense variants that have clinical significance from those that do not. While there are many computational pathogenicity predictors available, I specifically tested 7 programs: MutePred2, Panther, PhD SNP, Polyphen2, Provian, SIFT, and SNPs&Go. These were chosen for a few reasons, including their ability to analyze data from any animal species, in other words, not just humans, their reported performance on human data, and their public availability, meaning they were all free to use. The equine dataset that I used included 165 benign missense variants and 46 pathogenic missense variants. In order to run my dataset through these programs, I had to first pull the protein sequences for each variant and then enter them in one by one into each of the 7 programs. Once I had all of the data back, I ran some basic statistics to evaluate the performance of each of the 7 programs, including sensitivity, specificity, and accuracy. At a high level, I found that while the top performing program for the horse was SNPs&Go, the majority of the other programs performed almost equally as well. Notably, this was very similar to what we saw for the dog, where SNPs&Go was also a top performer, but again, most programs had equally good performance. Furthermore, for both the horse and the dog, the worst performer by far was Panther. Going forward, we plan to test these programs on additional veterinary species, including the cat and the cow. Ultimately, the goal is to create a decision tree using a combination of these programs that can be applied for effective pathogenicity prediction of missense mutations in a given companion animal species. Thank you.